In this question, we're using differential equations with related rates of change. Firstly, let's identify the information that we're given in the question. We're told that a rate at which the water flows from a hole in the base of a cylindrical tank of cross-section 30 centimeters is given by the differential equation dv dt equals minus 3 root h. So we have the formula dv dt equals negative 3 root h. We're told h represents the depth of the water, v is the volume of the water in the cylinder. The first thing we're asked to do is find dh dt. Writing down the information that we know. We're told the area of the cross section was 30. We're told dv dt equals negative 3 root h, and we've been asked to find dh dt. So, considering the related rate, dh dt is what we've been asked to find. We've been given dv dt, so that means we need to find dh dv. So we need a relationship between h and v. Remembering that we're dealing with a cylinder, we're told the cross section of the cylinder was 30. We know the height is h, so we know we've got a regular prism there. The volume of a regular prism is equal to the area of the cross section times its height. The area of the cross section we were told was 30, so we know volume is equal to 30h. We now have a relationship between v and h. So differentiating that with respect to h, dv dh is equal to 30. We need dh dv, so taking the reciprocal of both sides, dh dv is equal to 1 over 30. Substituting information we know into the related rate formula, replacing dh dv with 1 over 30 and dv dt with negative 3 root h, we can now multiply those together, and we now know dh dt equals negative root h divided by 10, as we were asked to find. Considering the second part of the question, we're told find the time to the nearest minute, so time to the nearest minute, so find t, required for the tank to empty. Well, if the tank is empty, the height will be 0. But we are told the original height is 2.56. So we know h is equal to 2.56. Because that was where we were starting from, that means time is equal to 0. So we have a point of information. H equals 2.56, t equals 0. So let's go back and solve that question. In part A, we came up with a relationship dh dt is equal to negative root h on 10. Taking the reciprocal of both sides, dt dh equals negative 10 on root h. So we now have an expression that we can anti-differentiate with respect to h. If we did that, we would get t equals the integral of negative 10 over root h dh. Before we anti-differentiate, we can simplify that by taking the negative 10 in front of the integral sign and taking the root h up to the top line as h to the minus 1/2. So when we anti-differentiate, we add 1 to the index power and we get h to the positive 1/2, and we divide by that positive 1/2. Tidying that up, that gives us t equals negative 20 root h plus c. Now remembering the information we were given about that point, t equals 0 when height is 2.56. Substituting that into the formula we just generated, we can solve for c, and we get c equals 32. That means our relationship is t equals 32 minus 20 root h. We now have a formula relating t and h. So we now want to find t when h is equal to 0. So substituting 0 into our formula, we get t equals 32 minus 20 root 0. Simplifying that gives us 32. Hence, the tank is emptied after 32 minutes.